So I just saw this question on Reddit, and it's pretty much asking, how can we have more solutions besides the ones that we can easily tell? And since I have done the first two equations already, so today let's focus on x to the 6th power is equal to 1. If we look at this equation, it seems that 1 is a solution because 1 to the 6th power is equal to 1, but also negative 1 works as well. Negative 1 to an even power gives us positive 1. So we have plus or minus 1. We should be done, right? Well, in fact, these two are the only real solutions for this equation. And to answer your question, when we have a polynomial equation, pay attention to the degree, which is the highest power. In this case, we have 6. So we can expect to have 6 different looking solutions. Real plus complex. So in fact, these two are the only real solutions for this equation, and we have 4 other solutions in the complex world. Sometimes you may have an equation with just one answer, but it's repeated a few more times. I have a video on that. A cubic equation with just one solution, but it's counted 3 times. So go ahead and check that out. The link will be in the description for your convenience. So we're going to go ahead and continue find out the other 4 complex solutions. To do so, put the 1 to the other side. So we have x to the 6 minus 1 is equal to 0. Then try to do it by factoring, because I think in the beginning of learning the complex numbers and all that, we do it by factoring. Do we have any other methods? Yes, but maybe later on. So it's kind of fun to factor out a difference of 6 powers. How though? Well, notice this right here is saying, okay, I don't have a formula for the 6th power directly, right? But I have the 2nd power, the difference of 2 squares formula, and also the difference of 2 cubes formula. So we can look at this as x squared to the 3rd power, yeah? And then 1 is the same as saying 1 to the 3rd power. So if we look at this as the difference of 2 cubes, we can continue. And we can also look at that as x to the 3rd power and then to the 2nd. That will also give us 6. And then the minus 1, that's just minus 1 to the 2nd power. So which one's easier to use, or they are both okay? I'll give you a little hint. If you are doing the difference of 2 6 powers, start off by using the difference of 2 squares formula first. This right here will work, but it will be trickier at one step. I can work this out later on for you guys, but for now, we're just going to focus on this. So I'm going to look at this equation as x to the 3rd power and then squared minus 1 squared, and that's equal to 0. I'm going to review the formulas that we need to factor difference of 2 squares for you guys. So here, note. Here we go. If we have a squared minus b squared, this right here gives us a minus b times a plus b. And that's the difference of 2 squares formula. In this case, a is x cubed, b is just 1. So apply this formula to this, we will get x cubed minus 1 times x cubed plus 1. And that's equal to 0. Now, we have a difference of 2 cubes, one side 1 cube. Likewise, a sum of 2 cubes. In fact, both of them are factorable, so we can continue. So, note, here we go. If we have a cube, let's do the minus first, b cube. This gives us a minus b times a squared plus ab, right? Minus plus, and the last one is also a plus, b squared. And notice there's no 2. It's really just this, a squared plus ab plus b squared. For the sum, this is very similar. A cube plus b cube is equal to, no, that's a 3. This is equal to a plus b times a squared. If you have a plus here, this is a plus, this will be a minus, right? And then ab. And lastly, you still have a plus, b squared, like this. So in our first case here, we have x to the third power minus 1 to the third power. So let's just use this formula first. So a is the x and then 1 is the b. So use this formula, we get x minus 1 and then just continue. X squared and then plus this times that, which is just x, and then plus 1 squared, which is just 1. Right? This is the same as 1 squared. Perhaps I put this down, same thing. Right? So we're done with that. Now for this one, we are going to use the second formula, pretty much the same thing. So we will have x plus 1 and then times x squared minus x times 1, which is x, and then plus 1 squared, which is 1. So just like this, and that's equal to 0. Now, we cannot really factor anymore with the usual method, right? So I'm just going to put each factor equal to 0 and then solve for x. From here, x minus 1 is equal to 0. That means x is equal to 1, and that's one of the real solutions. And then for this one, x squared plus x plus 1 equal to 0. Let's solve it by using the quadratic formula. And to do so, x is equal to minus b, which is the 1 right here, right? And then plus or minus square root of this 1, which is the b, squared minus 4ac. A is 1, c is 1, so it's 1 and 1, all over 2 times a, which is 1. Okay, and then let's see. We get negative 1 plus or minus square root. This is 1 minus 4, which is negative 3. So negative instead of a square root. This is not real anymore. See? And then over 2. And we can put the negative on the outside. Imaginary number. So this right here will give us, perhaps already done, negative 1 plus or minus I square root of 3 over 2. Alright, so we have 2 more solutions from here. So this is the first one. And then we have 2 more right here. Now, x plus 1 equal to 0. Of course, that's just x is equal to negative 1. So, yeah. And then finally for this, x, let's label this. This is number 1, 2, 3, 4. Last one, x squared minus x plus 1 equal to 0. And then just do it again. X equal to negative b. In this case, it's negative 1. Plus or minus square root of b squared, which is negative 1. And then minus 4ac. A and c are both equal to 1. All over 2 times a. And now it will give us positive 1. And then plus or minus square root. This is 1 minus 4, which again is negative 3 over 2 times 1, which is 2. Yeah. 1 plus or minus, put the I here, and then square root of 3 all over 2. All right.